Hello students, welcome back to my second lecture on inverse trigonometry. This is senior maths teacher Rana sir. Actually last lecture I discussed about inverse trigonometry, the very basic part, and I just solved some questions from where you get to know the chapter. Now this lecture completely I will discuss different varieties of question. So I will start with some simple questions and how to use the formulas for solving question. So let me start with a simple question. Let me take tan inverse 1 by 2 plus tan inverse 2 by 11 equals to tan inverse 3 by 4. Question is this: we need to prove that tan inverse 1 by 2 plus tan inverse 2 by 11 equals to tan inverse 3 by 4. So let me show you how to do this. So let me consider the LHS of the question. This is tan inverse 1 by 2 plus tan inverse 2 by 11. So tan inverse x plus tan inverse y. If I simply go from the formulas which I was discussing last day, it is tan inverse x plus tan inverse y. So this will be tan inverse x plus y by 1 minus xy. That means this will lead to, if I take LCM, it is 2 plus, not 2, it's 11 plus 4 by 22 by 22 minus 2 by 22. So 22 and 22 cut. I'm getting now, this is 15 by 20. 15 by 20, which is tan inverse 3 by 4. It's very simple, students. What I am doing is that simply I am applying the formula. On application of formula of tan inverse x plus tan inverse y, I am simply getting this. Now this can be minus also out here. So another different proving will be there if it is a minus. Then in that case what will I apply? Tan inverse x minus tan inverse y. Same way I can apply sin inverse x plus sin inverse y, cos inverse x plus cos inverse y. So I am taking one more example from this concept of formula application. Now the question is tan inverse half plus tan inverse 1 by 5, half plus tan inverse 1 by 5 plus tan inverse 1 by 8. They are asking to prove this is pi by 4. So what will I do? First I will use tan inverse x plus tan inverse y within this two. I am clubbing this two first. So let's see what happens. LHS tan inverse 1 by 2 plus 1 by 5 by 1 minus 1 by 2 into 1 by 5. So tan inverse, this is 5 plus 2 by 10 divided by again this is 10 minus 1. So 10 cut. This is tan inverse 7 by 9. But with this side I have tan inverse 1 by 8. Tan inverse 1 by 8 plus tan inverse 1 by 8. So first what I did, I applied tan inverse x plus tan inverse y on these two parts, and as a result I got tan inverse 7 by 9 plus tan inverse 1 by 8. So then what happens next? What I will do is that I will apply formula within these two. Now what will I do? This is tan inverse 7 by 9 plus 1 by 8 by 1 minus 7 by 9 into 1 by 8. Now this will change like this now. It is 7 8 ja 56 plus 9 by 9 8 ja 72 by this is 72 minus 7. So this and this cut, result is tan inverse 65 by 65 is cuts, and I am getting tan inverse 1. Now see, tan inverse 1, this one is what? Tan pi by 4. So tan pi by 4 means what? Tan pi by 4, and this tan inverse pi by 4 goes to the range of tan. So tan and tan, if I remove it, I will get simply pi by 4. That's the proving. It's very simple how I am applying the formulas for solving such inverse trigo question. I can take one question of cos inverse. Cos inverse 4 by 5. Let me take one simple question for sine inverse or cos inverse. So let me take a question of cos inverse. Cos inverse 4 by 5 plus cos inverse 12 by 13, and they are asking that proof this is equals to cos inverse 33 by 65. So how will I prove this? Again, let me start with the left hand side of the question. It is cos inverse x plus cos inverse y. So cos inverse x plus y by 1 minus xy. Now if I apply this formula, then what happens? Oh no, mistake. This is not the formula for cos inverse. What happens is that cos inverse x plus cos inverse y. So cos inverse x root over 1 minus y square plus y root over cos inverse xy means it is 4 by 5. Sorry students, I have done a mistake. I am applying the formula once again. It is cos inverse 4 by 5 into 12 by 13. Cos inverse x plus cos inverse y formula is cos inverse xy minus root over of 1 minus x square into root over of 1 minus y square. So this is cos inverse x plus cos inverse y. So cos inverse x into y minus root over of 1 minus 4 by 5 square into root over of 1 minus 12 by 13 square. Now if I do this, what happens? This is 12 4s are 48, 13 5s are 65 minus, it is 16 by 25, 1 minus 16 by 25. So 25 minus 16 is 9. So 9 by 25 means I am getting 3 by 5 into, this is 144 by 169. So 169 minus 144, it's 25. 25 by 169. So it is 5 by 13. So this 5 and 5 is cut. So I am getting cos inverse 13. This is 65 is the LCM. So 48 minus 13 5. 5 3 is a 15. So 48 minus 15, that means it is ultimately what I am getting? I am getting cos inverse 33 by 65. So this results me cos inverse 48 minus 13 is 33 by 65. I suppose students it is very easy application of formulas of cos inverse x plus cos inverse y. And I hope so it is very much clear and the explanation also is easier. Let me take some question on range. Range, actually last lecture when I was explaining you that sine inverse range is minus pi by 2 to pi by 2 close interval. Again cos inverse it is 0 to pi close interval, and tan inverse minus pi by 2 to pi by 2, but it is open interval. So there is a difference. Again sec inverse, cosec inverse, cot inverse, all these 6 ratios only, there are some range. So let me take one example. Sine inverse 2 pi by 3. The question is sin inverse sine 2 pi by 3. Now what happens? This 2 pi by 3 is not in the range of sine. So let me write like this. The range of sine inverse is actually closed interval minus pi by 2, 2 pi by 2. See, actually I know the range of sine inverse is minus pi by 2 to pi by 2. But this is 2 pi by 3. 2 pi by 3 means 120 degree. If you consider pi as 180 degree, this is what? 120 degree. So 120 degree is not lying on the range of sine. So I cannot remove sine inverse and sine, and I cannot put the value as 2 pi by 3. Then what I have to do? First I have to bring this sine 2 pi by 3 onto the range of sine inverse. So let's see, how will I do that? I will write sine inverse sine pi minus pi by 3. Students, it's very simple. This is 120 degree, 2 pi by 3. 2 into 180 by 3, it is 120. Now 120, I can write 180 minus 60. That's what I've written. Now this is in second quadrant. Sine in second quadrant is positive. So what happens? Sine inverse second quadrant, I will write it sine pi by 3. So I got here sine inverse sine pi by 3. Then what happens? This pi by 3 is lying onto the range of sine. So as this pi by 3 is lying onto the range of sine, so I can easily remove the sine inverse and sine. So my final answer is just pi by 3. I hope so, students, this is clear. I will take 2-3 more examples for such type of questions, and it is very, very important. Let me take one more question. Tan inverse tan 3 pi by 4. Now again 3 pi by 4. If you calculate this, we get 135 degree. If I consider pi as 180, so I am getting what? 3 pi by 4 as 135 degree. But tan inverse range is minus pi by 2, 2 pi by 2, but this is what? Open interval. Minus pi by 2 to pi by 2, open interval. This 3 pi by 4 is not lying onto the minus pi by 2 to pi by 2. So what will I do? I have to change this 3 pi by 4. So tan inverse tan, I am writing it pi minus pi by 4. Now tan inverse tan pi minus pi by 4, this shows that this is in quadrant 2. Quadrant 2 tan is negative. So negative means tan inverse, it will become minus tan pi by 4. Students, please take note of this step. What happens? This is negative. Why it is negative? Because tan in second quadrant is negative. Now tan in second quadrant is negative, so one minus comes out. So what happens? I am getting minus tan pi by 4. But tan inverse minus x, I have explained you the formula in my first video, that tan inverse minus x is simple minus tan inverse x. So what I am getting? I am getting simple minus tan inverse tan pi by 4. Now this pi by 4 is on the range of tan. This pi by 4 is lying on the range of tan. As it is lying on the range of tan, so I can easily remove this tan inverse and tan. So the answer will be minus pi by 4. I hope so, students, this is making the concept of the range more easy and more proper for you all. I am writing one more question. This time I will write a question with cos. A bit different when we do with cos. It is cos inverse cos 7 pi by 6. Now cos inverse cos 7 pi by 6. What happens? 7 pi by 6 is more than 180. So, and cos range. Range of cos is closed interval 0 to pi. Now, cos inverse cos 7 pi by 6, 7 pi by 6 is not on the range of cos. It is lying outside the range of cos. So what I have to do? Same working method. I will write cos inverse cos pi plus pi by 6. Now 180 plus 30. This 7 pi by 6 is 210 degree. If I take pi as 180 degree. Now it is pi plus pi by 6. That means 180 plus 30. So you are in quadrant 3. Now this is in quadrant 3. Quadrant 3 cos is negative. So cos inverse minus cos pi by 6. Students, please take note. This step is very, very important. What actually I am getting here? As this is in third quadrant cos is minus, so negative cos pi by 6. Now there is a minus out here. Cos inverse of negative. What happens? I am writing pi minus cos inverse cos pi by 6. I explained you these formulas while explaining my normal basic concept of inverse trigonometry in my first lecture. Now I got here pi minus cos inverse. Students, please take note of this step also. What I have written here? I have written pi minus cos inverse cos pi by 6. Now this cos pi by 6, this pi by 6 is on the range of cos. So I can easily remove this cos inverse and cos. So what happens? It is pi minus pi by 6. So pi minus pi by 6, it is 5 pi by 6. That is the answer, students. It's so simple. So I have discussed with you all 3 questions on ranging. That is one with sine, one with tan and one with cos. So special note should be taken, special care should be taken while working with the question of cos inverse, sec inverse and cot inverse, because the minus out here leads to pi minus cos inverse, or in case of sec inverse also, in case of cot inverse also we get what? Pi minus. I hope so, students, this is very much clear. Let me take some more examples, some more questions of inverse trigonometry. Next, I will use some questions in this form. Sine inverse x plus cos inverse x. Now, they are asking simplify or find the value. You should take care that this sine inverse x plus cos inverse x, how we solve this? Sine inverse x plus cos inverse x is basically pi by 2. While explaining the formula, I told you sine inverse plus cos inverse is pi by 2. Sec inverse plus cot inverse is sec inverse plus cosec inverse is pi by 2. Tan inverse plus cot inverse is also pi by 2. So it is sine inverse x plus cos inverse x. Now this is sine, basically this part. This part, if you see properly, we can write it what? We can write it pi by 2. Now sine pi by 2 means sine 90. It is 1. So simple this question is. I will take similar type some more questions. I am taking one most very important question, the popular question for examination point of view. Sine inverse 1 by 5 plus cos inverse x is equals to 1. So the question is sine inverse 1 by 5 plus cos inverse x is equals to 1. And they are asking find the value of x. So what I will do now, I will use the same concept like the previous question. I wrote sine inverse x plus cos inverse x equals to pi by 2. I will use that idea to solve this. Now this is sine inverse 1 by 5 plus cos inverse x 1. Now this one I am writing it sine pi by 2. So please take note, this sine and this sine, I can easily remove this. If I remove this, what happens? Sine inverse 1 by 5 plus cos inverse x pi by 2. Now students, please take note of this thing. The previous question, when I was solving, I explained the sine inverse plus cos inverse is pi by 2. Here I am getting sine inverse 1 by 5 plus cos inverse x equals to pi by 2. Now when this is possible? When is sine inverse plus cos inverse pi by 2? When these two are equal. That is sine inverse x plus cos inverse x is pi by 2. When these two both are x. So if this is x, this is 1 by 5. So what I can write? I can write therefore x equals to 1 by 5, and that is the answer. I hope so students, this is a very popular question. The question marking comes to be 1 marks, but still it is a very important question. So I hope so it is clear. Let me take some more question now. And I'm moving on to the solving part of inverse trigonometry. Solving question using inverse trigonometry. So I have a question, tan inverse 2x by 1 minus x square plus cot inverse 1 minus x square by 2x, that is equals to pi by 3. They are asking solve for x. So what will I do? This is tan inverse 2x by 1 minus x square. Let me keep it same. 2x by 1 minus x square plus. This is cot inverse. So I will change this as to tan inverse. So 2x by 1 minus x square equals to pi by 3. Now this is tan inverse 2x by 1 minus x square by inverse trigo formula. This meaning is directly 2 tan inverse x. So directly 2 tan inverse x, what I can do? I can write this one as 2 tan inverse x. Again same here, it is 2 tan inverse x. That is equals to pi by 3. That means now what will I do? 2 tan inverse x plus 2 tan inverse x. It is 4 tan inverse x equals to pi by 3. So this 4, if I take it down, it will become tan inverse x equals to pi by 12. So what I can do is that now tan inverse x equals to pi by 12. So x equals to tan pi by 12. Now what happens? X equals to tan pi by 3 minus pi by 4. See, actually I have split this into the form of pi by 3 minus pi by 4. Actually 60 minus 45 means it is 15 degree. Pi by 12. If I take LCM, I will get pi by 12. So x is equals to tan A minus tan B by 1 plus tan A into tan B. Now tan pi by 4, this is 1. No, this is tan pi by 3. Tan pi by 3, this is tan 60 means root 3 minus tan pi by 4, which is 1 plus this is 1 into root 3. So ultimately the value of x which is derived from this solution, x is equals to root 3 minus 1 by 1 plus 1 into root 3. So it is root 3 plus 1. You can leave the answer here, or you can rationalize it one more step to get to the answer. So students, solving question, this is one of the very important question. One first question I have done for solving. Let me move to some more question of solving. A very important question. This question has come for the board examination. Tan inverse 2x plus tan inverse 3x, that is equals to pi by 4. Now they are asking solve for x. So what will I do? I will write tan inverse a plus b by 1 minus a into b, which is pi by 4. So tan inverse x plus tan inverse y. I have written tan inverse x plus y by 1 minus xy. Now this tan inverse, if I shift this side, it will become 5x by 1 minus 6x square equals to tan pi by 4. Now tan pi by 4 is 1. So this changes into a quadratic equation. So 6x square plus 5x minus 1 equals to 0. Actually what I am doing, this is 1, so I am cross multiplying, then I am transferring everything this side. So minus 6x square, this side it becomes positive 6x square, then it is 5x, and then 1, if I shift this side, it is minus 1. I need to simply factorize it now. So what happens? It is 6x square plus 6x minus x minus 1 equals to 0. So 6x common, x plus 1 minus 1 common, x plus 1 equals to 0. So x plus 1, 6x minus 1 equal to 0. So two solutions are possible out here. One case I am getting x equals to minus 1, the other case x equals to 1 by 6. Students, take note of this. If x is negative, so tan inverse 2x plus tan inverse 3x cannot be pi by 4. So this is not possible. So only this is the solution. So this is the solution for solving of this question, where I am getting x equals to 1 by 6. I suppose this much examples are more than enough by which you understand how we solve questions of inverse trigonometry, students. So last question for this lecture, students. I will take one more question. Question is 9 pi by 8. A simple proving question. Minus 9 by 4 sine inverse 1 by 3 equals to 9 by 4 sine inverse 2 root 2 by 3. 2 root 2 by 3. So this is a simple question and it's a proving question. I am moving out from the solving part. Proving. So let me take the left hand side of this question. What will I do? I will take 9 by 4 common. So if I take 9 by 4 common, what is left with me? Pi by 2 minus sine inverse 1 by 3. Now, it is known to me by the formulas that sine inverse x plus cos inverse x equals to pi by 2. Now, sine inverse x plus cos inverse x is pi by 2. That means, if I write like this, cos inverse x, it is pi by 2 minus sine inverse x. I can write like this. Means very simple. What I am doing, I am shifting the sine inverse to the other side. Taking that concept, it is pi by 2 minus sine inverse 1 by 3. So what will happen? 9 by 4. So 9 pi by 2 minus sine inverse x, if I take it, it will become cos inverse 1 by 3. But my proving is sine inverse. So what will I do? I will change this by the concepts of triangular method. See, the base by hypotenuse 1 by 3. This is root 8 by Pythagoras. I hope, the students, this concept I explained in full detail in my first lecture. So 9 by 4 sine inverse, if I take, it is sine inverse perpendicular by hypotenuse. That means root over of 8 by 3. Now root 8 is what? 2 into root 4. 2 into 4 and root. So 4 square root is 2. So 2 root 2 by 3. That's the proving. and it's up. And very important questions for student. That's it for the lecture 2 on inverse trigonometry, students. I will again come back with my third lecture on inverse trigonometry, where some more question solving method I will explain you all. Thank you, students.